definitely this section is required. All of this is required. And the reason is this. If you go around looking at other tutorials on C++, there are plenty on YouTube. All the ones that I've seen start at the level of the abstraction. That is, they start talking about C++ at the level of what C++ was designed to accomplish. So, in a sense, they're assuming that you already understand what the thing is and why it was designed in the first place. C++ is all about what they call abstraction. And what I want to do is approach it take it from the other way around and start it from the non-abstract, let's say, point of view, and talk about how you can abstract something. And that's what a function is about, in a sense. Every computer system, like this one or yours, has, if you drew a schematic diagram, maybe I can draw one, there's usually something, a big complicated mess of diagrams, and at some point, there's a box. It always has the same name. I don't know why, but it does. It's as slow as this. I'm trying to make this faster. Okay. In between the devices and the operating system, like the keyboard and so on, there's a box, and they always call it this. HAL. That has a definite meaning. That's called what they call the hardware abstraction layer. Okay. So on this side you have devices, real physical things. Then there's something called the hardware abstraction layer, and then there's the operating system. Now, what this layer is designed for, and one example of a hardware abstraction layer is a BIOS. It's not the only example, but what this thing is for is to hide the complexity of all these devices and sort of normalize things so that what comes out this side is always the same, always in the same format, so you don't have to worry about it. Okay? Now, what the people that designed C++ were interested in this whole concept of abstraction. Why? So the A here stands for abstraction. And this whole thing is called the hardware abstraction layer. Abstraction is the thing that the people that designed C++ were interested in making easier for programmers to do. Like, the concept of hiding complexity of devices from the operating system, so that every keyboard looks like a keyboard, like that. Remember the bias in thing. I told you we don't have to talk about in because the bias takes care of that for us and hides that bit of complexity so that when we look at a keyboard, We don't need to know, gee, is it a model such as 36701 ES2, blah blah blah, etc. We don't need to know about that bit. The bias knows, and the bias takes care of it and abstracts it away. That it turns the keyboard into what they call an abstract thing. That is, it's a concept. It's become a concept rather than a physical thing. And the people that designed C++ wanted to make a language that would make it easier for programmers to do that kind of thing with other things other than keyboards. And that's why I want to take this thing from the other point of view, from not starting with the abstraction and showing how to abstract. And that way we can understand what C++ is actually about. If you ask someone, why do you call this, in C++, one of the things they have, one of the words, buzzwords you hear all the time is this abstract class. This such and so is an abstract class. And I bet if you asked anyone, your teacher or whatever, what's an abstract class, they're going to provide you with this answer. Oh, that's easy. An abstract class means it has virtual functions. Has virtual functions. Okay. Great. Then you say, okay, well, what's a virtual function? And then they explain a little bit about virtual functions. But really, you haven't learned anything. All you've done is taken one word now and turned it into another word. I mean, now you have two words for the same thing. You haven't learned the concept of what an abstract class is, or why they call it abstract. But this, you understand, is easy enough. The keyboard is complicated. We don't want to see that level of complexity. And the BIOS takes away some parts of that complexity so that we don't have to worry about it. And that's really what an abstract class is about. It's about hiding detail that you don't want other people to see. Abstraction. From the first level of abstraction, the first method of abstraction that people came up with was the idea of a function. So suppose we know this much. You can declare an int. What I want you to do, what somebody asks you to do, is design a system so that I can write I equals, okay, and then any name I make up, call it foo, and followed by some brackets, okay, and what I want it to do is any complex operation I want, and store the result of that operation into this variable called I. Okay? So that is the task of designing a function. Now, given what we know, how could we do that? What we know from debug. How do we do it? Our one method. Okay? So get I into foo. Method 1. A compiler will somehow supply the address, and then jump, using what we know about jump over to foo, perform calculation, and then store the result in I, and then return somehow, get back. Okay. Now that only leaves one problem. Well, it leaves several problems. But if you look at this line, this is an assignment already. Okay. So it's not so good if we do the assignment and jump back, because there's already code. We've already designed assignment. If we already have, I'm assuming this, we have code for this. What we want really is for foo to represent a number rather than all this jumping around and addresses and so on. So there's a problem with the method in that although it works, it's a bit of a lie. We're lying about this syntax. This isn't really an assignment. It's the same in C world. This would be the same as having a new function called foo1, which basically pointed to I, pointed to int, and this line is really the same as foo address of I, right? And then moving to the next line. Let's just so that's the return part. So call foo of address of I, and then resume here. So in that way, we're lying. We're not assigning I the value as a value as if this foo represented a number. What we want is for this whole statement to amount to a number. Okay? So what we do is look at how does this work? And this is not a diversion, this is critical. How does this work? According to what we know already with the assembler stuff. Okay? So that is the first question I want to ask. And I want to answer it. Now let's see how we might do that.